Hello and welcome to the Streamline Spline Emission Custom Sampling Setup tutorial. This is essentially part 2 of the Streamline tutorial series in which we go over different ways of how to set up and use the Streamline system. What we're going to do now is we have our old emitter from the last tutorial. Part 1 will be linked in the description. And what we will do with this is we will use our sampling settings to provide a custom sampling of this spline. So this is going to be dealing a lot more with this data sends map we have here. And we will start with making sure we have a refresher on what these do. This spline subdivision value here will divide up the entire spline into this many sections. And each of these sections will have its endpoints sampled, and those will be where the particles can spawn from. So if I just have one subdivision here, the entire spline will be that one section, and particles can spawn at the beginning or the end of the spline. However, if I crank this up to 2, the spline is now divided into 2 parts, and it is going to be sampled from the beginning, the end, and the middle point. And then this can continue 3. We would have beginning, and then end, and then another 2 points in between that would divide this into thirds, and so on and so forth. And then this coordinate space down here would determine what space these points are calculated in. So what we will want to be doing today is we will want to be subdividing this emitter into specific locations along this spline. So what we will first need to do is go into our emitter and make sure it can receive the information that our blueprint will be sending it. So inside of our Niagara system, when we want to subdivide this spline based off of samples from the Streamline blueprint, we can go to whatever module we wish to do this in, go to Show Advanced, and then up here we'll see this position array. And to get the data from the Streamline blueprint into this Niagara system, we will need to create a user variable that will send that information to the Niagara system from the Streamline blueprint. Now, normally you'd think you could go here and create a user variable this way. However, I've noticed some issues with doing that. What we'll want to do is we will want to come over here to the user exposed variables and create a new position array, since this is the type we are looking to satisfy here. And this will be called sampled spline points. This will pretty much be all of the points along the spline that have been sampled by the pattern the Streamline emitter blueprint has. So we can save this and go back, and we will notice nothing has really changed. And this is because none of the data is actually being sent. Here in the data sense variable, what this does is it controls what data is sent to the Niagara system. And why these are all off is because we want to be able to save system resources and prevent warnings when we don't need any of this data to be sent. Because this can generate warnings if you have something checked here that does not have a receiving variable in the Niagara system. As we can see here, we have gotten a warning that the override parameter sampled spline rotations for this system has not been found, and that is because such a parameter does not exist inside of our system, so it cannot contact it. So we leave these off when we do not have these parameters to stop warnings and just to save time for the Streamline system. However, we want our position now, so what we will check is, if we check the position, we can see that we are all spawning our points now from this lower end. Now you might be wondering why it's not spawning from the upper end, since it should be doing that too, since it spawns from both ends of a segment. So if we go to our spline fountain, we can see that in our spline U, it is not set to the entire spline. So that is one important thing to note, is that these spline subdivisions will ignore any of these spline U ranges you set here. So make sure that you set up your subdivisions correctly so you get what you want within your spline U range. So if we want to see the full spline, we can set these back to 0 and 1, save it. And when we head back, we see we now have particles appearing at the base and at the top, just as it should. So now what we can do is we can change these subdivisions. If we move it up to 2, we have the start of the spline up here, middle of the spline, and the base of the spline are spawning particles. And then we can continue this process 3, 4, 5. And so as we can see, we have 1, 2, 3, 4, 5 different sections, all spawning particles at their ends. And what we can do is if for whatever reason you need your emitter to have these things sampled in local space, we can switch this to local. We'll notice in this case our particles disappear. That is because they are now where they are at locally, which is under the ground here. But we can switch this back to world space for now. And that is pretty much how to send sampled spline data from the blueprint into Niagara. And we just use all of these checkboxes here. And if for whatever reason you accidentally edit one of these strings to something else, we can go over here to the reset, we can reset it, and then just resample the position again, and it will work just fine. Now there are these proximity targets data sends you can have down here, and these will be covered in the next tutorial. But as of now, we are just worrying about the subdivision and sampling in general. Now if we go back to our spline, we can see that we have these sampled spline points right here, but this is not the only case where that's someplace you can enter sampled values. You can also go down here to the radius area and you can input sampled spline directions and up vectors. What these will do is they will help define the radius of a spline at any of these given points so it can have a segmented radius. And these values are derived from the blueprint the exact same. If we want these, what we can do is we can make a new vector array and call it sampled spline directions. And we can make a vector array called sampled spline up vectors. And we can plug both of these into their respective array spots, so directions and up vectors. And we can apply these. Actually, first, let's make sure we have a radius to see. So I'm just going to use a radius of 30. Got a nice ring there. That will be what it will do at each one of these points. So as of now, it's moving, so it's kind of hard to see the ring. If we go back in here, turn off any velocity that is possibly applied, we can now see we more or less have these rings appearing around these points. And they're not perfect rings, and that's because what's happening here is when you get all of the particles of the spline, they are spawned first, in this case, using our random mode. They're spawned randomly on the spline and then randomly on the radius from there. And that happens before they are segmented into these chunks. So they will be clamped to wherever the nearest chunk is. So that's why you kind of get these two ring-like structures here instead of just one solid one, is because you're getting particles from all along this closest section of spline being clamped to this one area. If you turn this up, it will start to look more even because you have more particles in a more local area being sent to that one spot instead of a wider region. So now we start getting more of these well-defined rings along the spline. And one last thing to note is it may look pretty good now, but Technically, what you should do is make sure that your up vectors and directions are being sent there as well, because why it looks good even without that is you were sampling from such a small region that the up vectors from that region are going to look very similar anyway. So now when it is sampled with both the up vectors and directions being sent, we actually do get these more cohesive rings yet again, even at smaller values. So it's important to make sure that you remember to check these boxes. Anyways, that mostly wraps up what there is to talk about on the custom spline sampling. This will sort of carry over into the next tutorial on what is called proximity targeting. However, there's a few things left specific to this. First of all, it's worth mentioning that when you're sampling anything from the spline, any of the user variables are prefixed with sampled spline and then what you want, and make sure that it is plural. So if I want a sampled spline point, I will write out sampled spline, then I'll write out points plural. Same with up vectors, I'll write sampled spline up vectors plural. For more details on this, you can go see the documentation. It's in section 5. Anyways, one last thing to mention, these do not just apply in the modules, there are also individual dynamic inputs. So if I go to the spline position, I can also input my spline points array into here, and I will get my spline position out of there based on those points. Anyways, that mostly wraps up this tutorial. If you found this video helpful or informative, don't forget to hit the like button so you can help other people find this video. And don't forget to subscribe to Galacticc Games and ring the bell so that you can get any information on updates from Galacticc Games. And you can also join the Galacticc Games Discord community to engage with others using products such as Streamline. Thank you for watching, and I hope that you have learned and better understood how to use custom spline sampling to your advantage in creating your streamlined spline emission systems.